Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 12, Part 5, multiple linear regression, qualitative independent variables, and interaction terms. All right, as a reminder, we are in a situation where we have one response variable and many x variables, x1 down to xk. We can write this in the form of having n subjects in our study. And for each subject, we're going to have a vector that is yi, and then each of the observations for x1 down to xk. We'll label these xi1, xi2, and so on up until xik. So every row, right, this is row 1, all the way down to row n, right? That is, each row is 1 per subject in our study. Whereas the columns, right? Column 1, column 2, and so on. All of our columns are the different variables. So the columns represent the variables. All right, the multiple regression model can be written in general form as y equals beta 0 plus beta 1 x1 all the way down to beta k xk plus epsilon. But we could also write this model per person, right? So we could say yi equals beta 0 plus beta 1 xi1 plus ... beta k xik plus epsilon I. So every single person becomes a row. So we'd have, for the first row, y1 equals beta 0 plus beta 1 x11 plus all the way down beta k x1k plus epsilon 1. And then for our nth subject, yn equals beta 0 plus beta 1 xn1 plus all the way down beta k xnk plus epsilon n. All right, so this is our linear regression model that we have. Remember that for multiple linear regression, the y value, the response variable, is quantitative. The x values can be a mixture of quantitative and qualitative variables. So for example, the y value could be the forced expository volume in 1 second that you breathe out. It could be the time to finish a race. It could be salary, right? There's so many examples. Quantitative variables, these are continuous variables, right? But our x values could be a mixture of quantitative and qualitative variables. So for example, we could have BMI, we could have weight, we could have gender, right? That's a qualitative variable, categorical variable. We could have low income status, right? That's also qualitative. We could have ethnicity or race, right? We could have number of years in school. That's quantitative, right? And in a previous section, we talked about how to interpret our beta hat j's if our associated variables are continuous, right? In general, we would say a 1 unit, using the correct units, a 1 unit increase in x is associated with a beta hat j unit, you fill those in, increase or decrease in y. Now, everything I've underlined are things that you're going to replace to make it in context of the problem. However, if we have a qualitative variable. So no longer quantitative, we have a qualitative variable. And say we set up an indicator variable. We're not going to use the word dummy variable. Let's use an indicator variable. So for example, let X equal a flag for gender being female. So X is going to equal 1 if female, and it'll equal 0 otherwise. Right? So this is an indicator variable because I'm indicating who's female and who is not. So if we wanted to interpret this beta hat J of our associated variable, that's an indicator variable, we're going to say group 1 is associated with a beta hat J unit increase in Y on average compared to group 0 when all other X's, the variables in the model, are held constant. That's if your beta hat J is positive. If your beta hat J is negative, you'd say group 1 is associated with a beta hat J unit decrease in Y on average compared to group 0 when all other X's in the variable, those are the variables in your model, are held constant. So this is fairly straightforward when we don't have interaction terms. So in general, let's say we had, age, right? And then we have IQ scores. And let's say we were taking kids who are 5 up to 15 years old, right? So essentially, if we have a prediction line, and let's suppose we had 2 lines that were parallel to one another. So let's say that X equals 1 if the child is in an accelerated program, accelerated math. If the child is in accelerated math, and 0 otherwise. So essentially, if we have these 2 lines, they can show the difference between this is the accelerated math group, and this is not an accelerated math. So essentially, as age increases, IQ scores increase, but the people who are in accelerated math, there's this difference here, right? Which is showing the effect of being in accelerated math. All right, I hope you learned something today about indicator variables. There's some vocabulary to focus on. Multiple linear regression. Remember that our response is quantitative and our predictors can be a mixture of quantitative and qualitative variables. And that the way we interpret our beta hat J's associated with those variables will change whether or not you have a quantitative variable versus a qualitative variable.